everyone. If you guys can hear me, could you please give me a green check? Thank you, my friends. If you hear me, could you please give me a green check? Thank you. I need to hear from you and Eric. If you're there, could you please give me a green check? All right. I hope you guys are staying warm. It's a little cold outside. Start with our lesson for the night. Lesson 13. And remember, what we did last week, we did raceways and wireways. And before that, if you guys remember, we did conduits, metallic conduits, non-flexible conduits. So tonight, we're going to continue. We will continue to talk about wiring methods, and we'll highlight a very interesting and important wiring method, which is the flexible conduits. The flexible conduits. So that will highlight the flexible conduits tonight. When we're highlighting the flexible conduits, metallic, non-metallic, liquidtight, and so forth, we're going to touch on the cabinets and the gutters. I know last week, if you guys remember, we talked about the gutters a little bit, but review it one more time tonight. And so the main topic would be really is the flexible conduits and cabinets. What are cabinets, cutouts, and so forth. Does anybody have any questions, guys, about last week? Any questions about last week? Have done in the past. I always go over what we tested out last week. Some of you guys have been emailing me. I hope I able to get to your all emails. If I forgot an email, please remind me. There's so many things going on with update 111, and so we're busy, I guess. But if I forgot to get back to you via email about anything, please let me know. So, Kevin, I still haven't heard from you, my friend. I'm going to make sure that you're sitting down there. So with that, friend, we're going to go ahead, as we have done always in the past. We're going to go review the quiz. I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 in particular I want to highlight based on the percentage of less 70 that you guys scored with. So, okay, the first thing, guys, remember we talked about wireways and raceways, metallic and non-metallic last week. So that was the topic for the week. So where such metallic wall thickness is this amount or less, the voltage between the conductors shall not exceed, and our answer for that one is 300. 300. So that's basically, if it's this amount or less, then the wiring cannot be, the voltage cannot be less, cannot be more than 300. On to the second one, and I usually move fast, so stop me at any time, buddies. The need to permit surface meter raceways to be installed, and our answer for this one was D, which is exposed dry location, dropped ceilings, under raised floor, or data processing equipment, no problem. B, power line conductors may be installed in raceways with signal and control cables. Number 3, and our answer for number 3 is D. I want to highlight this one, guys, especially this one. It says wireways are contained in a separate containment. Separate is the key point. The interior of each compartment has a different contrast color, and the relative position of compartment is maintained. Intermix them. So basically, can I put low voltage and high voltage in the same ways or raceways? No problem, as long as you maintain complete section and identification of the two chambers. Number surface meter raceways may not contain more than how many conductors, and number 4 is B. Now remember, we're talking about raceways, surface meter raceways, 30 conductors. Otherwise, you have to apply the 310.15b2. So 30 conductors at any cross-sectional area, provided the derating factor are applied to them. I emphasize, guys, for raceways, metallic and non-metallic raceways, I can put as many conductors as I want, as long as if I want not to derate, I have to limit the current carrying conductor, the hot conductors, and the neutral that carry current to 30, as we remember, as we said. Number 5. And stop me at any time. Raise your hand if I'm going too fast or too slow or something. Splice tabs in surface raceways should occupy. Now remember, it's splice tabs and occupy, not more than. And our answer for that one was C, 75%. And that number, guys, will go with you all wherever you go. In cabinets, you can't occupy more than 75%. If you have splice and tabs. So that's not a big deal. So that was number 5. Number 6, my friend, the conductor fill of surface non-metallic. Surface metallic raceway is not permitted to exceed percentage of structural area. You know, a lot of you guys get this wrong for one reason. Because I believe you were confused between the wireways and the surface raceways. It was a wireway, then 20%. You can't fill more than 20%. But because it's a non-metallic raceway, it's not a wireway. So then there is no limit. The limit is by how much the manufacturers want you to limit them. I think there is a condition, Brenna, my friend, if you fill 20% and if the cross-section area was, I think, 4 inches or larger, and you maintain these are for the metallic anyway, and if you maintain 30 current carry conductor or less, then you don't have to derate. But then for derating, how many conductors I can put in a non-metallic raceway? As many conductors as the manufacturer allows us to do so. So get confused between the 20 that comes from the wireways. So that's probably why a lot of you guys got that one wrong, because you get confused between wireways and raceways. Oh, number 7. Number 7 is surface non-metallic wires are not permitted to be installed. 7. In C, not permitted in concrete location. In concealed location. Number 7 is in dropped ceilings. Surface non-metallic raceways are not permitted to be installed in dropped ceilings, floor, all of the above, in concealed location. These ways are not meant to be concealed. They're not meant to be concealed. I know you can go through the partition, guys, but that's not concealment. Complete concealment is they're not meant to be concealed. Number 8, guys, this source for guidance on support for non-metallic raceways is, again, don't get confused between it's the manufacturer's instruction. These are not wireways, these are raceways. You have to go supportive based, and I told you guys, remember, I said that's based on the manufacturer's instruction. Number 9, where the thickness of the multi-outlet assembly this time is this amount or less, the voltage between conductors shall not be less than voltage shall be conductors shall be less than which voltage? So number 9 is A. Number A. The thickness of multi-outlet assembly is less than 0.04. The voltage between conductors shall not exceed. That doesn't make sense here. Shall less than 30 voltage. It shall not exceed 30. Anybody can see? Shall not exceed 300 volts. Anybody wrong? Oh, that one goes for you. Number 9. Number 9. Okay. Okay. Any comments with this? Number 9. Any questions? So limited to 300 volts or less. And metal multi-outlet assembly may pass through a partition F. D of the above in dry. There is no receptacle in the wall. The cover of the exposed portion can be removed. So pass through, not concealed. Pass through. Number 11. Number 11. Wireways are permitted to be where exposed to. Number 11. Our answer was B. Severe damage? No. Corrosive environment? No. Or vapor? None of the above. Of course, is not an option, so our option is a wet environment if rain tight and listed for the purpose. Are permitted to be installed where exposed to if they're in wet location if they're listed for the purpose. So 11, Number 12, the maximum flow of conductor permitted is a wireway. Now we're talking about wireways. Raceways. And number 12, our answer was D, obviously, which is the 20%. I can remind, I can't emphasize, it's a wireway, it's not surface, metallic, non-metallic raceways. Wireways installed horizontally must be supported at intervals not exceeding 8. Again, we know everything about wireways. Raceways is what we need the manufacturers for. 3. Number 14, my friends, metallic wireways installed vertically must be supported at intervals not exceeding 414, and we have D. Number 15, we have D is 15 feet, right from the NEC code book, no mimic. Surface metal raceways are permitted to pass through some partition. Access to the conductor is required with raceways pass through. Number 15, D, which is the walls, the partitions, and the floors. We have to have access. Access to the conductor is required where raceways pass through. So you have to have access from both sides of the wall, from both sides of the wall to these conductors. Okay. When splices or taps are made in a conductor installed in non-metallic raceways without removable cover. Here's the key point here: without. There is no cover that this for raceway that you can remove. So number 15, the answer is A. I can't emphasize the word without removable cover. That's the key word. They must be installed in a J box. If the cover can't be removed, it's an EMT conduit almost. It's an E conduit. 17, my friends, is one that I want you guys to pay attention. Mitchell, multi-out assembly main, number 17, and our answer for number 17 was D. Be run with partitions if they are dry. Partitions, it passed through partitions, but then run within. Be within partitions if the cab is removed. Be within partition if the outlets are covered. So it passes through, but not run within. I guess language, the lingo here. So you cannot cover it with partitions in any way, shape, or form. Number 18, multi-assembly are not permitted. Answer is C, which is in hoistways for elevators or for elemental air or whatever. And to have the sides or back surrounded by the building finish, no problem. You can surround it in location to be assessed and baseboard heaters, no problem. You just can't install it in a hoistway that could be used for, I guess, elevator, or could be for environmental air transfer or whatever the reason for this hoistway is defined as number 19. Our definition is B, a type of raceway, flush, freestanding raceways to hold conductors and receptacles in the field or at the factory. Number 20, and the last one, my friends, is metallic wireways are, and our answer for this one was D, which is sheet metal trucks equipped with hinge or removable cover filled with conductors after the inter has been above, and it would be number D. Anything else about the quiz? Any questions? I flew through the quiz. But if you notice, what we're doing, guys, is we're walking you through the most important wiring methods in the code book. Remember, we started with the PVC, we started with the non-flexible conduits, EMT, rigid PVC, intermediate, and all the stuff. Then moved to raceways, and now tonight we're going to do okay. And from I'm just looking at your chat, guys. And from tonight we're going to be doing the flexible metallic conduits, and non-flexible conduits. So we're walking you guys through all these nice wiring methods. And the reason for doing this, Joe, my friend, is because as an electrician, you walk into a situation, you have to find the best material, the best approved wiring methods out of the 40 to 50 wiring methods in an NEC code book for that particular application. So I know a lot of you guys, if you're in a commercial building, EMT it and MC it. A lot of people can solve 99% of their problems by an MC cable and an EMT conduit. No problem. We talked about that. This is your probably conduit of choice and a cable of choice. Now, today, guys, we're going to talk about the flexible conduits, and that can work. I always think flexible conduits, guys, they almost can do the work of an MC cable. It really is. A lot of stuff that you can solve with an MC cable, with an advantage of you can add as many conductors to this flexible conduit as you desire, based on the need. We're going to talk, guys, about the physical characteristics of wiring methods and equipment based on a flex. Use permitted for the two types of flex. Requirement that applies to installing the flex. So these are a few things that we will be touching on tonight. The first, let me ask you guys, how many of you will have? So we're going to talk flexible metallic conduits, liquid-tight flexible metallic conduits, and that's the second one. And the third one, we're going to use flexible non-metallic conduits with three types that they have. So I'm going to do my presentation. I'm going to flash my NDC code book here, and then when we're done with this, we'll do some exercises, probably about how many conductors you can fit in them and so forth. And then after that, we'll touch on the cabinets and so forth. Okay, before we start, I'm going to ask you, so we're going to start with the flex. To help me, I have a couple of things here. So flex conduit number, we're going to talk about where do you use the flex, number of bends, flexible conduits, metal conduits, and connectors. That's basically what we're going to do. We'll go ahead, guys, and talk about flexible conduits. There's a few things you have to know about flexible conduits. Flex conduit, Joe, is not your conduit of choice when it comes to wiring the whole building. Most important thing about flexible conduits, metallic, non-metallic, and Liquidtight, is connection to equipment. This is the key point. It's not meant to wire the whole building with it, though you can if you want to. It's not the wiring methods, put it this way. So connection to an equipment, very interesting. If in wall or ceiling spaces where installation of rigid raceways is impractical. So basically, if I am to put a number one use of flex is really connecting to equipment. So equipment could be an air handling unit. Because of vibration, here's my big air handling unit right in here. Here's my disconnect over here. I bring my EMT right in here. And then after I get my EMT, I bring my Liquidtight flexible conduit and tie it to my air handling unit. One application. The other application, guys, is I have my lighting fixture here, and I have a J-box, right? I have my EMT coming from it. And what do? I bring my flex and I flex it all the way to my lighting fixture. So that's a very common application, tying to equipment, tight machines, unit. So that's the major use, basically, of flex, really, the use of flex. An application of flex is not as common as connection to equipment. If you want to fish a conduit in a wall, so in walls and ceilings, insulation, if you fish a conduit in a wall, not a cable, a conduit, fishing an EMT or rigid or PVC might not be the best way of doing business. It's hard. So sometimes using them for remodeling, fishing conduits in a wall, they come handy, though it's hard to work with them really, unless it's for distances. You can't fish them in a wall and go 50 feet and pull the conductors on them. Good luck trying to get the conductors through. Pulling fish in the wall, that's another one. So these are basically this where you don't want to use it. Used for surface wiring, and because it looks so heavy. So this is not a conduit that you're going to use for surface mounting equipment. You're not going to surface mount it for feeders and branch circuits and so forth, because it's not as neatly layout and bent as EMT, rigid, or any other conduits. Anything else about the use of the flexible conduits? Any flex, anytime. It's not just metallic, could be the non-metallic or the liquid type. Any questions? And so really, if I'm to emphasize one thing, it's really tying to equipment, and sometimes it could be handy when it comes to fishing in a wall conduit. I ask you this question, guys: how many of you have used flex to tie equipment? Flex type equipment. I bet you all of you probably have used some type of flex to tie the equipment. Tie to a lighting fixture, tie into a machine, so flex as in Liquidtight or flexible metallic conduit, Liquidtight, or non-metallic conduit. So, okay, ask you this question, buddies: how many of you guys used it to fish it in a wall for modeling? Fishing it in a wall to modeling, fishing flex in walls to do remodeling. Okay, so some have used it also to fish in a wall. What's the difference between fishing flex and fishing EMT? I mean MC cable. MC cable limited by the number of conductors they have, while flex you can pull as many conductors in it as you need. So really, the question is always comes is why can't they use an MC cable and call it a Chad? Especially if I want to fish it in a wall. Well, what if you need to fish to pull, say, 6 conductors? Are you going to custom design yourself 6 conductor MC cable? It would be easier to go pull a flexible metallic conduit in a dry wall and just pull these 6 conductors into it, sized appropriately. So that's basically what is so common. Any question, guys? Any question about that? Seems a lot of you used it. So start, guys, by flex metallic conduit, the most commonly used, which is flexible metallic conduit, and then go to the Liquidtight, and 338. So, and we'll touch on the Liquidtight and the other ones. So 330, 348. Okay. Basically, what we're going to be doing, let's look at the flexible metallic conduit first. Joe, my friend, that I'll be repeating myself from last week because we are dealing with conduits and rules for conduits are identical. For example, how many bends you can do between pull points for any conduits? Well, 360 degrees, Chad. Doesn't matter if it's a flexible conduit. Doesn't matter if it's non-flexible conduit. No. So that we cannot maintain, we can have more than 360 degrees between points. Otherwise, you have to put a pull point. The problem with the flex, guys, is it's easy to exceed it when it comes to flex because flex moves it's a flex, so it moves. Look at that one coming from here. Now, counting how many angles between here and here have I exceeded. So it's so easy to exceed it with a flex, as you can see. That's why flex is. Now, should I always ask Kevin is when you fish that in a wall, especially a long distance, do you really know if you exceed 360 degrees? I guarantee you, sometimes depending where the wall is and where location, you can easily exceed 360 degrees. So that's basically, but not ideal if it's fished in a wall, I guess. But the idea is not to exceed 360 degrees, which is very hard with a flex. It really is. Events will make it difficult or impossible to install conductors. How many of you, let me ask you this one, how many of you tried to pull conductors in a flexible metal conduit and it was really hard? Anybody? Really hard to pull them? Okay, encounter this one. So especially if it's a long run, say 20 feet, 30 feet run going in a basement or something like that. I had a situation one time in a motel, and then so I pulled a circuit, and because I was so lazy, I don't want to use EMT, so I used flex. and I'm probably 30 feet to a gearbox and keep moving. I think it's probably 20, 30 feet. And in the conductors, even though I have access to the cable, it's suspended ceiling, so I can see it. And it was really pain trying to pull the conductors. So one thing you discover all the time that if you have metallic fish tape, then you don't use it. You have, I don't know if you guys have tried to use a metallic tape in a flex, and good luck try to push pull conductors. So the fish tapes, which is used anyway, it works really slick with a flex. At least I tried a couple of times, and then it's easier to pull them with non-metallic flex, not like a fish tape. That's basically it. It's really hard to pull these conductors if you're using them as a branch circuits or circuits or otherwise. A couple of things about flex, guys, were used as wire methods. Use fish tape. Obviously, we said the conduit has been stretched. Make sure it's stretched between the termination points to make it flexible. That's the key point, guys. With the flex, the key pulling conductor through it, if you're using as a tight equipment, wiring methods, it's really like they use in the 70s to use it as the Greenfield use it as a wiring method. It's really tough to pull conductors through it. So the key point, make it as straight as you can, if you can. Okay, must be approved for the type of the fixture connectors. You can't use an EMT connector with a flex. Flex has its own designed connectors. So you have to have listed connectors or listed connectors that goes with the flex. That we all know. Will shows the type of the raceway or the cable that the connector are approved for. All conduits, guys, all conduits have their own listed connectors that goes with them. I can't mix EMT with MC cable and so forth. So that's the key point before we jump directly into the flexible metallic conduit. A few about the flexible for users. So we'll jump directly, guys, on the flexible metallic conduit and just look at about the users of the flexible metallic conduit. So between secure gearbox and lighting fixture, very common. That's in a suspended ceiling. That's very common. That's probably with a lot of use. You don't want to use an MC cable. This is probably the most common application that you can use a flexible metallic conduit. Between a pipe and a motor. As I said, here's my disconnect coming over here. Here's my EMT conduit. Here's my air handling unit or chiller or whatever, or pump, and flex it. You're here and you're going to flex it all the way and you tie it to the equipment. For what? For flexibility, number one. For vibration, number two. So make ease of movement if it needs to move the machine to clear any or so forth. Ease of movement, flexibility, and absorb the vibration. Because if you go ahead and tie your EMT to a rotating object, the whole wiring system might be vibrating in your building and making all these noises, which is a lot of people don't like. Another one, we cannot be bent tight enough. Station that I've seen it used, guys, where what can come to my mind? It's if you have is a panel and EMT would do this. Here's my panel number one. Here's my transformer sitting right in here. Here's my panel number two. So if I want to go wire a 480 panel, I don't know how many of you guys have done that. I want to wire a 480 panel. You tie it to the transformer. Out of your transformer to the this is 208 panel, 208 120, and this is my 480. That's common also. What can't I rigid this one? It's a transformer. You really don't want to tie it to a transformer because of humming with you can EMT it or so. You can though. A whole lot of might not be a vibration, but it's a good idea if a flex with a few of these or a flex, especially bending conduit, small space, really hard to bend there. That's a good application for a transformer here. Let me ask you, how many of you have installed it this way? Installed flex this way? Flex from one panel transformer all the way to another panel. So that's a common practice. And in this case, you will pull the equipment grounding conductor or bonding jumper. Remember, not meant to ground. It's not meant to be your grounding system. Okay, so you lose your grounding. Where move or change of height will occur between electrical feed in and equipment. The equipment movement, we talked about this when things move, like in the machines, or change of height between the occurs between the electrical feed and the equipment. Back to tying to the equipment because of vibration or height or whatever. So that's another use for the flex. So to summarize, guys, tying to equipment, very big deal. To as in motors, transformers, and so forth. So fixtures all the time. Any comments, guys? Anybody has any comments about flex? And the use of flex, guys. Any flex Liquidtight or non-metallic based on that application. Okay, flexible metallic conduit has general 6 length of 4. Now, guys, to use flexible metallic conduit, equipment grounding conductor. Very interesting. If I have a fixture which is 4, so you have your lighting fixtures right in here. You have your 4 lighting fixtures, as you guys probably have seen. So you bring your J box right in here. Conduit coming in, conduit coming out, and for this box you go and you flex to this one, and you flex it to that one, and you flex to this one, and you flex to the other one. So here's my J box right in here, and each one of these is light and light and light and light. That's the application, guys, for a flex. Now, if your flex is 6 feet of fixture web, 6 feet or less, and if the circuit coming in, guys, is 3 amps or less, so you have a lighting circuit, amps or less, and the flex is 6 feet or less, then you need to pull an equipment grounding conductor. What that means is I do not need to pull right in here an equipment grounding conductor with each one of them. I don't need an equipment grounding conductor with each one of them. If it's more than 6 feet, then you need to pull an equipment grounding conductor, and that's for the fixture. So that basically the flex can work as a grounding means up to 6 flexible and or flexible Liquidtight or Liquidtight flexible or metallic, of course, or Liquidtight flexible metallic or flexible metallic. Any question, guys, about this? Using it up to 6 feet without an equipment grounding conductor. What it do? It saves you guys a wire. It just saves you a wire. Okay, so that's basically the common use of that one. Connectors. You have connectors. You can have a 0 angle. You have a 90-degree angle, or you have to have a 45-degree angle. So they can come right straight through. You can come with a 45-degree angle, or you can come with a right angle, right through 45-degree angle, right angle. So that's to trying to push things with a 90-degree angle. That's a pain. Okay, that's basically in terms of the flex. What flex? Here's how we define. If we don't know flex by now, it's a circular, as we all know, cross section made of helically wound, formed, interlocked metal strip. That's basically, as we all know, that green field is coming over here. You've installed many of them. So that's the definition of it. Uses permitted. Any questions before I keep moving? Any question about that? Any uses? You shall be used in exposed and concealed location. No problem. You can use it, and exposed shall be used in exposed or concealed location. That's the only thing that we worry about using. Anywhere as exposed or concealed. And 8, guys, they made a major change, and still the same in 2011, where they said you cannot use it in wet location. So if you have a rooftop unit, you want to tie the disconnect to the rooftop unit using a flexible metallic conduit, no, you have to use Liquidtight flexible metallic conduit. That just changed in 2011, and many people have installed them guys outside. But in 2011, you cannot use it outside, which is an wet location. It doesn't have to be outside. It could be any wet location. Hoistways for elevator, hoistways for environmental air, or any hoistways. They don't want you. There are some exceptions, but for the most part, it's not allowed. In storage battery rooms, this is not your conduit of choice. Hazardous location, with some exceptions, you can find a flex that you can use in hazardous location, class 1 div 2 or class 2 1 and 2. It has to be rated for hazardous location. Because, friend Joe, there are machines in hazardous location that I need to title for flexibility. So they may flex that you can touch in hazardous location. It has to be, of course, rated for that particular hazard. We're exposed to material having a deteriorating effect on the installed conductors, and material that you can, I guess that can apply for anything. They don't want you to put it in a place where it affects any material that can affect, deteriorate the installation of the conductors or the machines. And or embedded in poured concrete. This is not your conduit of choice to bury in concrete, and underground in concrete, or the most important, physical damage. If you have physical damage, believe it or not, if you have physical damage, well, why don't you go put your flexible metallic conduit in a rigid? Does that sound like weird? Putting a flexible metallic conduit in a rigid conduit, might as well just get rid of all of it together. So if it's both physical damage, then you cannot use it. It's subject to physical damage. And so, action guys about the use, it's really, as you can see, limitation. The main limitation is really wet location, guys. Wet location is the main limitation of that baby. The main limitation. The important thing about uses, so I can't emphasize, I can use it exposed, concealed, with limitation on certain areas, especially the wet location. This, you can get it from 1/2 inch all the way to 4 inches. So there is a table that can get you 3/8, and they use a lot with fixture width. They call them the fixture width. And there's a table, guys, that you can size. The conductor you can fit 3/4 inch flexible metallic conduits. We will get to it in a second here. But that's basically how we look at motors where you can use. So it says for thread number 3 for enclosing the lead. So they have limitation on the thread size 3/8, guys. Then metric list permitted by A1 through A5. So that 3/8, here's where they want you to use it. Number 1, using leads of motors, no problem. In length less than 6 feet, utilization equipment, listed assembly or tap connection to linear as permitted. Manufactured wiring, no problem. That in hoist weight as permitted in 620. We say that hoist weight, they are not permitted, guys, except there's some exception for them. After ballistic assembly to connect to web luminaires. So really 3/8 is not your wiring conduit. There's a limitation on 3/8, a lot of limitation on the 3/8, and there's a table for its own. Okay, it's a conduit not to sneeze on. It can get you all the way up to 4 inch. That's nothing to sneeze on, I guess, up to 4 inch. Now, conductors, guys, we're going to go to table number 1, chapter 9. If all the conductors are half, if the conduit is half all the way to 4, you're going to go basically chapter number 9 and table number 1. If that special little conduit size, only for this size, they have a typically table for you. And we can, my friend, in a journeyman exam, look at you. In a journeyman exam, Matthew, they have a question about how to use, they require you to go directly to table 348.122. They give you a 3/8 of an inch flexible metal conduit and see how many conductors say you can fit in a 3/4 of an inch flexible metal conduit. If you go to table 1, chapter 9, you're not going to find it. So basically, you have to go to the table directly inside the very important table. I can't emphasize highlighting it. Cable permitted to be installed. Can I put a cable, a multi-conductor cable or a single conductor cable inside it? No problem, as long as the cable article allows it. So for Brenna, can I put an MC cable? Ask me why I would do that. An MC cable in a flexible metallic conduit? Yes, no problem. In flexible metal conduit, you can put it in an MC cable. Why would that? A different story. So basically, can I use a 100 kcm cable, THHN cable? Can I use it? Yeah, no problem. So no cable shall not exceed the allowable percentage fill. So you can't fill more than 40%. You guys remember, for all conduits, the magic number for more than 2 conductors is 40%. No, this conduit is like any other conduit, no raceway, surface mounted raceways or ways. It's 40% fill. You cannot fill more than 40% of that baby. Any questions about the fill? Can't emphasize the 3/8. So please remember that 3/8, and I'll flip a few, and we can go with that table in a second. Okay. Bends, how many shall be made so that the conduit is not damaged when you bend it? The diameter of the conduit is not effectively reduced. Well, use a Chicago bender with this or hydraulic? No, manually, as you without any auxiliary equipment. Shall be permitted to be made manually. You don't need a hydraulic bender to bend a flex. Rate curve from the center of any bend shall not exceed that shown for other bends in table 9 for other bends on the bend. So that's basically for bend table under. I can't emphasize. If you go to table A2, guys, there's the other bend, and you go under other bend and to what's the minimum radius that you're supposed to bend this without. And so Joe might say, well, what the heck are you talking about, Chad? It's a 1/2 inch to 3/4, no big deal. But what if you are using a 4-inch, right? Remember that example that we said transformer to a panel? Now I'm using a big boy. I'm using a 4-inch to carry my conductor. That's a big conduit, guys. So if I'm going to, so I have to go and try to find the actual radius. Now, if it's a big conduit like this, 4-inch. So 1/2, 3/4, guys, an inch, and so forth. Not a big deal. It becomes a big deal when you have 2.5, 3, and higher than that. You have to pay attention to the minimum radius of bending for these babies. So typically, it in terms of bends, how many bends how many degrees as I bend them? No problem. 360 degrees. How do you calculate these? Good luck. That's okay. Good luck calculating how many bends you can do, because these are, how flex moves in. So it's hard, really hard to calculate between point 1 and point B. But like conduits, guys, between pull points, 6 degrees. Securing, my friends, as like, this is remind me of a lot of conduits, guys. MC cable and AC cable, 12 and 4.5. M cable is 4.5 and 12. So it's 12 from every point, with some exceptions. So here's my box over here. You put your first support at 12 inches, and you move 1/2 feet. Put your second support, keep moving. So 4 interval, 12 inches. Some exceptions that we'll talk about, but that main for 12 and 4.5 is really the main part. With some exceptions. So a couple of things. One of the exceptions, guys. So 12 and 4. One exception, as you can see, if I have for luminaires, For years, they allow you 6 inches. So look what they do. They come, and here's my ceiling right here. I don't know if you can see here. Here's my ceiling, and here's my EMT conduit. It came down to the first box. Here's my 6 feet, and I go to the second one. Here's another 6 feet, and now I go up another 6 feet. Again, another 6 feet. So you can from fixture to fixture to fixture, no problem, 6 feet. So we have a fixture, and then from here to another fixture, guys, 6 feet, no support. A third fixture, and as long as you maintain the 6 feet, you fixture to fixture to fixture. If you're more than 6 feet, then what do you need to do? You need to go up like I did right in here and support it. Any question, guys, about this? So fixtures, they allow you up to 6 feet. Very interesting for fixtures. And so fixtures, support of fixtures, length 6 feet from the linear fixture for tab connection to luminaire. Okay, length not exceeding 6 feet from last point with the rest with okay, for accessible ceiling or with an accessible ceiling equipment. The same thing applies, guys, if you have another machine. Yeah, also for another machine in the suspended ceiling up to 6 feet. Up to 6 feet. With lifted necessary after installation, length shall not exceed the following. Now, this is for lights and equipment in a suspended ceiling. What happens if you have a machine, guys, not in a suspended ceiling? They list, guys, they say 3 feet. They give you a whole list in page 196. If it's up to 3 feet, if the size is 1/8, half all the way to 1 1/4 inches, then from 1 1/2 inches all the way to 2 feet, and all the way up to 2.5 larger 5 feet. So tying to a machine, like a transformer, like a panel, you can go all the way up to 5 feet. Remember, it's not a fixture width. Fixture width is 6. But for other than fixture width, other than equipment in a suspended ceiling, so that's not in a suspended ceiling, not a lighting fixture, then they allow you to go basically 3, 4, or 5, 3 feet, 4 feet, or 5 feet for flexibility based on the situation. Based on the situation. As about the support, I can't emphasize it's 4.5, 4.5. The midpoint is 4.5, 12. Exceptions for fixture 6 feet, non-ported. Exceptions for flexibility to tie to air handling unit, chillers, equipment, transformer, you name it. They allow you to go based on size all the way from 3 to 4 to 5 feet. 3 to 4 to 5 feet. And my friend Joe, how about Chad? How about if I fish that baby? If I fish it right into a a wall, they don't need to support it. They don't want you to bust the wall so you can support the conduit to the box. They don't want you to do that. So if it's impractical to support it, they don't need to support it. Impractical to support, they don't need to support it. Okay, basically we got that one. Supports, as I said, when you support, here's your supporting means. Shall be horizontal supports by openings. Now, if you're pulling it in studs, and like they used to do in, I believe in the 70s, they used to wire with, I know houses wired with flex. If studs, guys, if you can maintain, and just imagine from this hole to this hole is 4.5 feet, and I know there's more studs than what I showed. I'm just showing 2 studs, 4 feet, guys. They don't need to support it. And go all the way to the last point, and here's my box here, and I tie it, support it, and I get close to 12 feet from the box, then I don't have to support. So if openings through framing members at intervals not greater than 4.5 and tie 12 from termination, it's considered supported. It's like a cable, guys, an AC cable and an NAM cable as it goes through the holes of studs. That's basically the magic number. Okay. Ground ratio. Truth when it comes to grounding. If you are tying because of flexibility, which is, we always thought that for equipment, is after you install the flexibility and equipment, you have to put an equipment grounding conductor, which, Kevin, my friend, 99% of the time when you tie to equipment, you tie it because of what? Flexibility and vibration coming out of it. So what do you need to do if you're tying to equipment? The option then you need to pull an equipment grounding conductor. What you lose, I lost the ability to use the conduit as my equipment grounding conductor. That applies only for flexibility, okay? And flexibility, usability and vibration. Now, link fixture is not flexibility is not required after installation. It shall be to be used as an equipment grounding conductor based on this rule. And let's go to this rule, very interesting rule, which is 250.18. So if you please go to 250.18 with 215 and just look at 50.18 and look at what the requirement, and I mentioned the requirement, guys, but I'm going to do one more time. And there is the end.18. This is page 114. And by the way, see my friend, this one's on test 2. This one's on the German exam test 2. So the equipment grounding conductor, if you guys look at number 5, 250.11.8.5, liquid flexible metallic conduit meeting all of the following. Number 1, you have to have listed fittings, not any fittings. Number 2, overconstruction device can be 20 or less. Number 3, the leads cannot be less than 6 feet. Number 4, we use to connect the equipment where flexibility is necessary. Equipment grounding conductor must be installed. So all these guys are met. When all are met, then use a flex as an equipment grounding conductor. And we're on it, guys. If you look at underneath it, Liquidtight flexible metallic conduit, the one that we're going to be seeing later. The same, guys, for metric, okay, conduit are protected by overconstruction device. For 35, for Liquidtight, guys, they the same thing with listed fittings and give you a listed number of amps that all the way up to 60 amps. And 6 feet, the same thing. We'll use connected equipment conductor. So we'll get that one in a second. Story short, to use it as an equipment grounding conductor, guys. Number 1, you need a 20 amp. That's one number 6 feet or less. Equipment being conductor. If it's flexible, like for machines. If it's for fixtures, you don't need it with fixtures. For fixtures, where unit equipment with flexibility is necessary after installation, equipment grounding conductor shall be installed. So if flexibility, then you can't use it. So that's basically it. With fittings are listed. So really is 1 amp or less, which applies to all lighting fixtures. If you guys are using lighting fixtures, that's exactly what we do lighting fixtures. You don't need, you just put in that side that hot and neutral. You ground the fixture to the flex. You ground the fixture directly to the flex. Teaching guys about grounding. I know old homes, guys, in the past, they're wired with this type of wiring, and you are not supposed to use it as an equipment grounding conductor. Now, my friend, in my old house in Richfield, my house also wired in 19 was built in 48, and it was wired with flex. I changed a few grounding receptacles to grounding receptacles. Tested the ground, just not scientifically, I guess. I just did it by shorting it. As a matter of fact, I shorted the hot to the flex. I'm able to trip the circuit breaker. That doesn't mean it works as properly, but I'm able to get 120 between the flex and hot. And when I shorted the ground to the hot, and I like to do that from time to time, able to trip the circuit breakers in multiple locations. And Eric, my friend, that was good enough for Chad to use it as a grounding conductor. So you have to pull an equivalent grounding conductor. It's used for more 6 feet, or if it's used for flexibility. Okay, any questions about grounding? I can't emphasize the importance of grounding. I can't emphasize the importance of grounding. That's basically couplings and a couple of things before I give you that. I'll give you a break and give you the full. A couple of other things I want to mention also: couplings and connectors. And connectors shall not be used for concealed raceway installation. And connectors, this was also on the test, guys. If you're using an angle connector, so equipment is coming in here, and your connector sits like this, and you're doing like this, angle connector. Angle connector shall be used on concealed installation. In 2011, they change this one. They say angle connector shall not be concealed. So they changed in 2011. Right now, it implies that it cannot, if this is kind of covered here, that can't be covered, like insulated. That's in 2008. In 2009, here's how they changed it. In 2011, guys, they say no problem. You can go and conceal up to the connector, which means because connector you don't want it concealed, so because pulling connectors in the right angle, guys, is a pain in the butt. You can't pull it. So they said you can, as long as the angle connector is not concealed, so you can take it out and pull your connectors and pull it in again. So that was changed in 2011. But the connector shall not be concealed. And splice and tab shall be made in accordance with the 300.5. If you're splicing or tabbing, you have to put J boxes and so forth. Grounding, we talked about grounding, couplings and connectors. So that's basically it in terms of let me see here. So can we just okay, and grounding. Speaking of grounding, my friend, thank you. Grounding, without getting Eric, that's from Eric. A grounding, Eric, in residential, you need to supplement your rod with another grounding system, which is most likely your water in your building. So that's basically what the code is. You need a grounding electrode system. If you decided to use the rods, then you have to supplement. If you decided to use the water, you have to supplement it by rods. And if you decided to use rods, you have to supplement it by water. So you have rod and water. Then, if the concrete encase is there, you have to use it. In a situation where the inspector, if they're pouring concrete and you're there, the inspector makes you put some type of a ray bar where you can tie grounding conductor. So it's a new construction, basically. So especially if there's no water, like say if there's no water in the shed or something, then they ask you to tie to the newly created concrete electrode. But if existing one condition, you don't have to go dig and bust the concrete to reach the ray bar to tie to it. So that's kind of been my experience. The ray bar was grounded in a panel already. Okay, I believe it's a new concrete. It's a new concrete. Eric, it's new construction. Okay, yep, absolutely. If it's a new construction, do you have water and rods? Rods is easy, but do you have a water line there? Real water line, copper? Yeah. So yeah. If it's, the idea is to have water line as well as rods. But if it's a new construction and concrete, they make you, I've been in a situation where they make you tie to the ground, to the rebar, concrete, so you can tie to it. That is, guys, every grounding, and reason, Eric, for this, because here's what the code says: you only need one grounding electrode system. I don't make a grounding tonight. One grounding electrode system. Only if you have a water or a rod, you have to supplement them with each other. That's so. If you steel a building, the steel of the building, you only need one. But if other grounding electrode system exists, you have to tie to them. That's how they catch you, Eric. Yes, you have your own grounding electrode system, but a concrete encased rebars, that's a grounding electrode system, right? So if it exists, you need to tie it to your system. That's why they're making you do it. Because new construction, then a big electrode system, concrete encased rebars, they want you to tie to it. So okay, without making it into grounding. Good one. I'm gonna go, guys, and give you the first poll for the night at 7:01, and then wait, do we have? Okay, have how many questions? That one. Okay, or question for you option. I'm gonna give you 5 minutes, guys, and then start, and that will take a quick break, and then we'll continue with flexible non-metallic or flexible metallic. Okay. Almost there. Okay. Okay. The one thing I want to emphasize, guys, is four. Number four, where there are two locations to find the number of conductors. One for the create conduit, and the table 1, chapter 9 is for everything else. So table 348.22 is only special table for create conduits. And I know you guys tell me about chapter. Okay, let me share the results with you here. Individual, great. Okay. Now to be reworded a little bit hard. I'm reading through it here. Let me see. Allow me to. Okay. So when is a separate equivalent conductor required for the metal? Length does not exceed 6 feet. The fittings are listed when it's required. Okay, all of the conduit is blah blah, and the conductors are protected when overcapacity over 20 amps. So all above, guys, is required. I mean, length does not exceed 6 feet. This is only an exception for fixture, but unless I tell you it's a fixture, if it's 6 feet or less, you need an equivalent conductor. The exception is only for fixture width. Things are listed as suitable for rounding. And if it's long, 6 feet or more, I know it's kind of confusing. If it's 6 feet or more, even the fitting is listed for grounding, you still have to ground unless it's a fixture. And the conduits 3/8 all the way to blah blah, protected by an overcompression. That doesn't mean anything unless you're tying it to a fixture. Unless you're tying it, guys, to a fixture. Let me. That's basically that. Okay, let's go, guys. And now it's 7:08. Let's go and have a break. Till okay 7:09. Let's make it 7:15. Let's get you guys 6 minutes here. Oops, that's a great color, huh? Yellow. Okay, 7:15. Let's go 7:15, guys. 7:09 here. Minutes to recoup here. You can check in, please. Thank you, my friends. Make sure to move on to the next topic for the night. So the name application, guys, is Liquidtight flexible metallic conduit. If you are in a dry location or damp location, not wet location, then you can use flexible metallic conduit. If in a wet location and you need flexibility, then you have no choice but one of the options. If you tie to an equipment in a wet location, your conduit of choice, number one, and you have flexibility and vibration, your choice because of the wet location will be Liquidtight flexible metallic conduit. So it's a flexible metallic conduit. What did they do? The smarter than Chad Kearney did. They added a Liquidtight cover, some type of a non-metallic cover. So all of the four main uses of flexible metallic conduit. You can use it anywhere. You can use it to tie to a lighting fixture. Use it in a wet location, dry location, damp location, no problem. Tie to equipment, tie to fixture, fish in the wall. So you can basically use it for any place that flexible metallic conduit have been used. Let me ask you this question: how many of you guys have installed this wiring system? Flexible metallic conduit or Liquidtight. How many of you guys have installed Liquidtight flexible metallic conduit? Commonly used in residential to tie the air handling, the air conditioning to the disconnect, stop units, air units, pumps. If in a wet location, it's where it's in a wet location, really. That's basically where you use flex. Then, my friend, if you can use a flex, it would be a waste of money to use Liquidtight because it's more expensive, obviously, the cover that they have. Can be installed in outdoor and wet location. Really, this is the key point. It's wet location. If I have to summarize one, the reason they have this baby is for wet location. We know that if 6 feet or is grounding, guys, but grounding, we're going to talk about grounding in a second. So this is only if flexibility is not an issue. If flexibility is an issue, then even though 6 feet or less, you have to ground. Okay. Do that, guys? They take a gland for sealing the lock nuts and connector to the box. So there's a gland for sealing the lock nuts and connector to the box. So everything is sealed here. Metal bushing that secures onto the liquid flexible conduit and brings the continuity to the lock nut connector. So the connector that comes with a special type of connector, and the idea obviously is to maintain the seal, the Liquidtight. So it's a jacketed flexible metallic conduit. The connector has lock nuts and seals that seal it completely against water. Last piece is bushings to tighten the gland, and this is just the connector, guys, that goes with it. And I'm sure I've seen it. We have a picture of that too, but those guys are sealing it. You do not want the water to seep right into the conduit, through the connector. So your connector is going to be a special type of connector with nuts and seals and so forth. Not any connector. Now, what is this guy? It's a raceway. It's circular, cross-sectional area. This is really the change from up to this point. We're really describing. Up to this point, we're really describing a flex. Here, outer Liquidtight, non-metallic, sunlight-resistant jacket. That's it. So that's what makes it Liquidtight, as we all know. And over what? Over the inner flexible metal core with associated couplings, connectors, fittings for the business of electrical wires, not for gas or anything else. So the point, guys, is that outer liquid, non-metallic, sunlight-resistance jacket really makes it tight in terms of water. Liquidtight. Anything else about this? So you don't want the water to get in. Liquidtight, flexible metallic conduit. Use is permitted. Moving on to like any other conduits, where can we use it? Exposed or concealed, bring it on, no problem. As follows: condition require flexibility, or so when is it required for flexibility, protection from liquid, vapor, or solid, So that's basically it, really. You can use it exposure concealed like slabs, but what makes you use it? Protection from liquids, vapors, or solids, mainly liquids in the application. Permitted, guys, you can use it also permitted in a couple of hazardous locations where it's specified for that particular hazard for flexibility. Now, can I direct bury it? No problem. Direct bury were listed and marked for the purpose. They them where you can go ahead and direct bury them. They're not meant to be direct buried. This is not the proper, the best installation for this conduit, but hey, no problem. It's them to be buried if needed. Advantage: you can get them listed to be directly buried. You put them in a flexible in location where you need flexibility and wet location because of liquids and so forth. The same thing, guys. Subject to physical damage. You don't want to use it in a place where it's subject to physical damage. And another thing, where the combination of the ambient temperature and conductor produce an operating temperature in excess of which the material is approved for. Now, my friend Kevin, this is a non-metallic jacket on it, so they don't want you to go put a 250 Celsius degrees Celsius cable inside that cable inside that conduit that will exceed, when it's operating, it will exceed the temperature rating of that jacket that engulf the Liquidtight flexible nonmetallic conduit. They just don't want you to put a conductor that when it operates, it will exceed what the non-metallic jacket is rated for. Remember, this, guys, it's all the time. If you have a non-metallic conduit, they always tell you you cannot put a conductor inside non-metallic conduit or anything that's non-metallic that will exceed the operating rated temperature of that non-metallic material. So especially for non-metallic. Metallic is not an issue. And since this guy has a non-metallic jacket, so the same rule applies to it. So let me the temperature of the install. Okay, this is no problem. Bring it on. You have from 1/2 inch all the way to 4 inches. The reception, guys, we're 3/8 of an inch. Same rule, 3/8 of an inch. The same rule, guys, 3/8 of an inch. With the flexible metallic conduit, we can use it for motor connection. We can use it for fixture. We can, so they you when you get the 3/8 of an inch, they refer you guys to 348.1A, which is we've finished 20A, and it's say no problem. Go tie it to the leads of a motor. 6 feet to tie to equipment or fixture, no problem. Manufactured wiring, no problem. In hoistways for elevators, problem, and enlisted assembly for wired luminaires, no problem. So that 3/8 is very limited application for it. For the part, I got 3/8 Matthew to my house. You can't 3/8 to your house. I use my 3/8 to tie a fixture to a J-box, enclose the leads of a motor, no problem. So I don't want you to think even that exists 3/8, except for the journeyman exam, because that's how they catch you. They catch you 3/8. Okay, so that's basically keep just a reminder for 3/8. Now conductors. Now conductors, guys, the 3/2 all the way to 4, you're going to go to table number 9, which we will go, table 1 chapter 9. So, and Annex C. Also Annex C, guys, it will tell you if all the conductors are the same, it will tell you conductors can fit in the Liquidtight flexible metallic conduit. Can I install a cable in this? Bring on, as long as the cable article does not prohibit the cable from being installed in. Example, can I install an NM cable in a Liquidtight flexible metallic conduit? Bring it on, Kevin, no problem. Can I install an SC cable? No problem, as long as the article allows you to do so. Okay, cable shall not exceed, and how much can I fill out of this baby? That, remember that magic number, 40% for all conduits, also applies for this baby. All applies for this baby. So this is for A, and 350.22, number of conductors, Liquidtight. So you're going to go directly, guys. For example, I have 1 inch. I can put 7 number 6 conductors THHN in that baby here, and this is directly from NXC. If all the conductors are the same, my friend, then you go directly to NXC inside them. No questions. Question is about going to NXC and finding how many conductors the same size you can fit in this conduit. Not a big deal, huh? Bring you to this side that you only need to remember for the exam, the journeyman exam, because that's how they want to trick you. So 3/8 inch. Oh, if you go to NXC, you're not going to find it. If you go to table 8, chapter 9, table 2, you're not going to find it. So they want you to go, guys, to a flexible metallic conduit table. This is a flexible metallic conduit table. They're referring you Liquidtight. They're referring you to the table in flexible metallic conduit. And very important, highlight this one for Chad and your own sake. And go there. They want you always to assume that the fittings are outside, and because that's what the situation with Liquidtight. The fittings are always outside of it. It can't be the Liquidtight. Very important. Fittings are outside. When we go to this table, guys, I'll show you what that means. You want to assume by code, if it's Liquidtight, the fittings are always outside. Now they catch you. This is conductor 3/4 inch. You can fit. Let's go like an example right here, guys. How many conductors? Liquidtight, flexible metal conduit. Okay, so here's an example. I have how many conductors? I have a 3/8 inch. 3/8 inch. Liquidtight, flexible metallic conduit. How many conductors can fit if these conductors are and the conductors are? Let's use the THWN since we are outside. THWN. Okay. Now, how many conductors can I fit? And the conductor size. What size conductor we want? Let's pick a conductor number 12. How many conductors number 12 can I fit in this one? Okay, so the question is how many conductors number 12 can I fit in 3/4 inch? In 3 inch. Now I'm going to shift up and go solve this one. Remember, it's number 12 THHN. 1, 2. So to this, now yes, we are dealing with my highlighter. Yeah, we are dealing with Liquidtight, but it refers us, guys, directly to, where's my highlighter again? One more time. It refers directly to flexible. So here's my THHN, my number 12. Can you guys see number 12 right here? Number 12, and I THW, and it says fittings outside, fittings inside. Remember, it says always by fittings outside. If it's Liquidtight, all fittings outside. Okay. And that's my insulation, THHN. So conductors can fit in this conduit, 3/4 inch, Liquidtight. I can fit only 3. I don't want you to get confused, guys, by saying here at the top it says flexible metal conduit. It refers you to that table from the Liquidtight article, so don't worry about that. All right. Okay, so that's been the 3 of them. I want to bring to your attention that they always get you in the test right in here. In addition, one insulated, covered, or bare equivalent grounding conductor of the same size shall be permitted. So, my friend Kevin, then how many conductors really I can do? You're going to tell me, Chad, 3 conductors plus 1 conductor ground. That's the answer. So it's 4 conductors. How many conductors I can fit in that? 3 conductors and 1 conductor covered, insulated, or it's used for ground. So it's 4 conductors including the ground. So let's see how many conductors include the ground that you can fit. All of them are THWN, THWN number 12 in a 3/4 inch. That will be 4. If they ask you how many conductors you can fit, no ground, the answer will be 3. Very interesting. So make sure you guys know how to use this table, because I know it's a new journeyman exam. Okay, any question, guys? Anybody has any question about how to use this table? Liquid flexible only, then you ask yourself, are fittings inside or out? So they have to tell you. They tell you, you can't tell because the fittings for flex, you can put some fit inside and some fit outside. Liquid, they're all outside. All conductors we found, based on our analysis here, we found it's going to be 3 conductors plus a ground, if they ask you about the ground, plus 1 conductor ground. Any question about using this table? Question about using this table? Okay, the bends, you don't have to damage the interior diameter, as we said, guys, for the bends, so don't reduce it. Will be permitted to be manually, so you don't have to pull your hydraulic bender and bend that 4-inch with that flexible conduit. And what's the minimum radius if I want to bend that baby? What's my minimum radius and where can I find my minimum radius? You can find it directly from chapter 9 under all other bends. On all other bends. That's exactly identical with the flex, identical for the flex. How many degrees of I can do between conductors? 360 degrees. If you measure them, good luck trying to measure all these angles between the flex, right? So it's really tough. But 60 degrees. Securing is an interesting situation. The same securing, guys, the same secure. Have to secure 12 from every box. 4.5 in between is my box. Is my 12. 4.5 in between. 4.5 and a 12. That rule. Exceptions. A couple of exceptions. Support. Let's just talk about the support. If you have an opening, as we said, the studs here and the studs here, and then in between them, go through the holes, no problem. 4 feet. And the last stud, guys, you come over here, you bring your conduit, and you tie 12 inches from the box, and you go. So that fits the hole. The support, back to the support, guys, there's some exceptions for it, exactly like the flex. For support number 1, in a wall, you don't need to support it because it's practical. If you are tying it for equipment, for installation, where flexibility is needed. So equipment, here's my disconnect switch here, and I went directly to Kersey, and then we pull conduit here, and I'm bringing my here, and this is my cable. We can go all the way. This could be 3 feet, depending on the size. This could be 4 feet, depending on the size, all the way to 5 feet for flexibility with an equipment or conductor. If tying it to aluminum, if I'm tying it to aluminum exactly like the flex, guys, I'll use 6 feet, up to 6 feet before you tie it. That's the fixture, no problem. And 6 feet from this is you fasten connecting with a okay aluminum equipment. So he catch you, Kevin, on this one. An electrical equipment installed in a suspended ceiling. So here is a machine, electrical equipment installed in a suspended ceiling. And how far you need, and can you install it with 6 foot without support? No problem. It connects right in here. Only if this machine is, or this electrical equipment like a transformer in a suspended ceiling. Now drop that machine down, and in a non-suspended ceiling, you put the machine right in here. Then that will drop your rest here into the bed when the conduit. It becomes 3 or 4 or 5, depending upon 2.5 inch or larger, depending upon the size of the conduit. And that's the exception. Very interesting. Very interesting. Any question about this? Depends where the equipment is located. The luminaires or other equipment, if it's in the suspended ceiling, from a point where the raceway is securely fastened for the connection within an accessible ceiling to a luminaire or other equipment. when this is securely fastened for connection within an accessible ceiling to luminaire or other equipment. Okay, that's basically the connection. We talked about the support membranes. Flexibility. Flexibility, guys, if you need a flexibility, which is that's why we use them, then you need to pull an equivalent grounding conductor, no question asked. There is rules for using it as an equivalent grounding conductor where there is no flexibility. So, Joe, friend, if you are tying it to a machine, you have to pull your equivalent grounding conductor. The time you don't need to pull an equivalent grounding conductor is if you are Kevin and Matthew, my friends, if you are using it to tie to a fixture, really is. Other than that, everything needs flexibility, vibration, and so forth, and fixtures. For they allow you to, really interesting how they do the guys. They go by sizes, and it's 20 amps. What they do, if you're using 20 amps for side half, I think up half, and a smaller 60 amp or less for 3/4 to a 1, and then you go to 60 amps, that will get you 3/4, all the size 1, and let's say the combined. Okay, so that's basically, and there's 35, I believe, somewhere in between. There's 5 somewhere in between. Here's the amp. So if your circuit is 20 amps and your conduit is 1/2 inch and listed connection and all this stuff, you don't need flexibility, and no flexibility is needed. Trade size 3/4 inch to a 3/4 inch to an 1.25 inch. As a matter of fact, 1.25 inch, that's not 60, that's 35, and then trade size more than 60, not more than 60, all the way to there is no flexibility is required. Trade size is metric. Trade size 3/4 inch, 1 inch in a grounding path. So they have a lot of for metric designator 1 through circuit conductor contained in the conductor by 60 amps, and there is no flexibility is required, or liquid flexible conduit and trade sizes. Okay, in this case, Liquidtight, that's where the 60 amps, that's where you 60 amps. So they can give you up to 60 amps, guys. And I'm reading page 115, where you can use it. Where would you use it at 60 amps? Flexibility is needed, and you still use it as an equivalent conductor. Okay, so the circuit conductor can open device 60 amps. There is no flex. Conduit flexible tubing or liquid flexible in the sizes of it. Okay, so that's for that 35. Some amps, guys, requirements and so forth. So, any question about this? Very interesting to read this when it comes to using it as an equivalent grounding conductor. It's different. There's different amps and different requirements for it. Still to be listed. Anything, guys, about the grounding? So that's basically for Liquidtight flexible metallic conduit. We talked about the grounding and the requirements for the grounding, support and stuff. Marking, it has to be marked. So that's basically it in terms of that baby. My questions, any questions about that? Any questions before we move into liquid flexible non-metallic conduit? Liquid flexible metallic. So what we did, guys, we explained, we went twice and we talked about we talked about flexible metallic conduit, Liquidtight flexible metallic conduit, and we see the only major difference, Joe, between them is really wet location. That's the major difference between them. Other than that, they are identical, and it's cheaper to use the flexible conduit. Now, one more conduit for you, if that's not enough. It's called Liquidtight flexible non. I emphasize the word non. This is your plastic non-metallic conduit. Nothing is metallic in it. And by name implies, Joe, anything non-metallic is perfect insulation for highly corrosive environments. That's it. Highly corrosive environment. Basically, nonmetallic comes mainly. That's an application, really is. So moving to this conduit, let's go ahead, guys. This is 356. Let's go to 356 and just a few things about this baby. Conduit or raceway comes in three types. There is type A and type B and type C. And very important that it comes in three types. So liquid, tight, flexible, non-metallic conduits. I can't emphasize the word none in all of them. On none. All of them, there's three types. There's three types. It comes again with all its associated listed, so you can't go and just come design yourself connectors and couple it with it. Okay, let's look at the uses permitted for this conduit. Very important. Where can I use this baby? Can I use this baby? I don't know if we have the, I don't think the definition for them. Okay. Okay, talk about let's start with the definition, guys. I have the definitions in here before we get into. So if you guys look at page 205, it listed a smooth, seamless inner core and cover bonded together and having one or more reinforced layer between the core and the cover, designated as type A. Now, type B is the same thing, smooth inner surface with integral reinforcement with wall. That B, a corrugated internal and external surface without integral reinforcement within the conduit wall. That's a C. So it goes by the type. That is an alternative designation for liquid flexible non-metallic conduit. Basically, okay, that's basically, my friends, is our conduits. The terms of the conduits, as you can read. Let's look at directly and where you can use them. All conduits, the key points, flexibility. This is your not conduit of choice to go wire a house from. The main point is flexibility. Where protection of the contained conductor is required from. Look at that. We need protection from solid, some type of a solid, some of a liquid. That's used non-metallic or vapor. And they have to be rated for that particular solid, vapor, or liquid. So you need to protect it, especially the liquid, guys, especially the liquids. Again, outdoor, this is non-metallic. That's your conduit of choice. Outdoor looking where, but it has to be listed from the sun, suitable for the location. But outdoor, can I direct bury that baby? Bring it on. And it's listed. They list them to be buried directly. Oh, type you use more than 6 feet of it for longer than for B only. You can use type B only. You can use more than 6 feet. Type B for listed, manufactured, pre-wired assembly, trade size. So that's the uses. I can use type B more than 6 feet, and you can use it also as a manufactured, pre-wired assembly, as we can see. Can I dye in a concrete and encase it? No problem. Look at the applicability of that one. Okay, thank you, Kevin. So that's basically the use. So look at the advantage of it. You can direct bury it. You can put it in a concrete. You can put it in a wet location or liquid location. And it's good for flexibility. So there's some advantage for using this conduit over liquid type. Okay, now prohibition. Where can I use it? Guys, severe physical damage. If you have a physical damage, might as well go have rigid metal conduit, guys, installed. With combination again, and this is a non-metallic series. Always ambient temperature shall not exceed what the conduit is approved for. So if the liquid flexible non-metallic conduit, it's rated for 90 degrees Celsius, you can't put a 250 degrees Celsius conductor in it because it defeats the purpose. In length longer, it's not meant to be installed in length longer than number 6. There's an exception that's coming for that one. There is a limitation on the voltage, and also an exception for that one for most time. Well, I mean, 600 volts is nothing to sneeze on, but it's not meant for high voltage, this conduit, while ours could be. in hazardous location, and there's some also exceptions where you can be permitted in other articles. There's some exceptions. Generally speaking, you can't more than 6, limitation of voltage, limitation of hazardous location, temperature, and physical damage. Any question, guys? Anybody has any question about this conduit? Of choice. Any questions? So that the issue of going on. So that's the size that you're going to come up with, guys. Again, look at the 3/4 that keeps creeping on us. The 3/4 all the way to 4, except there's a 3/4 that you have to be used, and there's limitation or how to use that baby. And it's going to go through that limitation. If you guys go directly for enclosing, the same thing, motors, guys, and fixture. So I can use the 3/4 for tying to motor keys and for tying to a fixture up to 6 feet. I can use it in our application. So supporting B. Remember that B that can be installed for more than 6 feet shall be fastened and supported in one of the following. Install the length longer if it's allowed. Remember that one you can install more than 6 feet. Then you have to secure it every 3 feet and within 12 inches of every box, J box or fitting. So only for B, the others they can't be installed. B, 12 feet. Okay, required where installed fished. If you fish it installed in length less than 3 feet, no problem. Where flexibility is required, or installed in length 6 feet if it's tying to a luminaire. Connection for tab or conductor luminaire. If you're having to feed a luminaire, no problem, up to 6 feet. If you're flexibility for an equipment, 3 feet, no problem. Otherwise, if you're using this wiring method every 3 feet and 12 inches, you have to support the equipment. Support these equipments. So 3 and 12, okay. This, anybody has any questions about this? What is okay securing? Okay, so that's basically it. Horizontal runs 3 feet to 12 inches. So 312 and 3 feet of flexibility, no problem. Here's my equipment here. My connect, grab it, and here's my equipment 3 feet, no problem. Not an equipment, just a lighting fixture. I can go all the way to 6 in this 6 feet. If machine 3 feet, machine 3 feet. Basically, your beam. Horizontal runs of horizontal runs in openings, the same thing, guys. Every 3 feet and every 12 inches. Required for B were installed in length less than 6 feet from this point that is securely fastened or connected to the luminaire, so you don't have to support it. Again, back to the luminaire in accessible ceiling. That's your fixture web. You don't need to support it if it's a fixture web. You don't support it if it's a fixture web. Alright, guys, basically every 3 feet and every 12 inches, fixture web 6 feet, means 3 feet flexibility, and only for B. Basically, that's B. C and A are not to be used for less than number 6 feet. So there's better cables. So it's only B. If I mean, emphasis coupling and connectors. All the fittings you can't custom design yourself. Anything else, guys, to use with it. Angle connector, the same thing, shall not be used with concealed. They change it from where concealed into where concealed raceway. They change it again from concealed raceway into concealed connector. The key point is not the raceway being concealed, it's the connector itself being concealed. You don't use the angle connector if it's concealed. In 2007, flexible fittings are permitted for direct, okay, so direct burial or encased in concrete, no problem. Remember, this is a conduit where you can throw it in concrete or underground, so the fittings will be listed for that one. So basically, I'm going to add a couple of things, couplings and connectors. Grounding. Ground, as you know, Bremer friend, this is a non-metallic. So what does that mean? There's no 6 feet and 3 feet and 20 amps and so forth. Non-metallic, you need to pull an equivalent grounded conductor where needed, which is 99% of the time you need it. And bonding if you need to bond. So you have to bond and ground as needed. So basically that's about it. I'll say about construction. B, as pre-wired manufactured, the assembly shall be provided in continuous length cable of being shipped in coil, reel, or curtain without damage. So the curtains, I'm going to flash them in a second here when we're done with that. Question is, any question about this type? Where do I use this type? If you have an equipment, guys, where highly corrosive environment, wet location, remember, I would use flexible non-metallic conduit type B to tie to equipment for 3 feet. There's a lot of limitation on it, though. So if I have to come from underground and tie to a machine and still maintain my flexibility, that might not be a bad idea for it. So let me ask you guys, how many of you have installed this wiring system? How many installed this wiring? Anybody installed it? Installed Liquidtight flexible non-metallic conduit. You can get away with a lot of application, guys. You can get away with Liquidtight flexible metallic conduit. Very places, well, there are some good places where you can use flexible Liquidtight flexible non-metallic conduit. The only thing that comes to my mind is the corrosion, concrete encased, corrosion, direct buried. That's when I'm thinking of flexible Alpha and C, especially type B. Okay, so with this, my friends, I'm gonna go get you my second poll for tonight, and then we will continue. So let me go ahead and use my second poll for the night. 8 questions. I'm gonna give you 5 minutes, guys, this time. Go ahead and start. We'll reconvene. Okay. Let's see. All right. Okay, so I'm going to go get the correction here, upload it. Yeah. So I hope that was a good review, guys, of what these three wiring methods. Questions, any comments? I'm just looking at your stuff. Any questions, any comments, guys? The chances, for the most part, everybody got that one. Is what about sizing, guys? How many conductors, number THHN you can use, permitted in 3/4 inch Liquidtight. And we did an example, and it should be 3 conductors. Okay? If I told you with a ground, then your answer should be 4 conductors. The ground, 3 conductors. So that's basically it in terms of that one. Let me just, I'll give you a break in a second here. Let me just flash, guys, a couple of things, just to round, as I always have been doing. Share my desktop and monitor 1. And roam around and show you a few things here. Let's start with that one. So here's I always like to go to Granger because it really seems to have a lot of good stuff here. So a few things, guys. I know you've seen a flexible metallic conduit. I have a really good selection of flexible metallic conduit, 1/2 inch. All the way, it's non-jacketed aluminum. 50 steel. Here's the prices. I'm just looking at this. All these are aluminum. You can get, here's a steel one, where application where you need a steel application, not aluminum. 7. Look at the price for them, from 36 for them all the way. If you go all the way to the steel, it gets you what is it, 1/2 inch steel to 790, almost double the price, aluminum versus the steel. Protection. So that's basically your wiring system, guys. 3/4 inch, 250, and flexible connection, aluminum. So that's a couple of. I'm going to go click on one of these, and you guys have seen a lot of them, and I'm sure we've wired a few of them here. It's a flexible metallic conduit, size 3/4 inch, straight size 3/4 inch. The length 50 feet. It's aluminum. And then it gets you, here's the price and all the other ships and blah blah blah. And I'm sure a lot of us guys have installed these over the years. So a lot of us over the years. So, okay, connectors. I'm just if you haven't seen the connector, a lot of us have installed the connectors, guys. So it says type insulated flexible right here, flexible connector. So as you see, you tighten right on it, so you can't use any other connector other than flex connector with a flex equivalent. So that's we see here. So a few things about the flex that I thought we can over. So that's my flex. I'm going to do steel again. This is my steel, 30 feet. Look at the price. It's a price. See, this is 3/8 of an inch. Again, this is not the wiring that we want to do. It's not. We don't like steel 3/8. Let's go to aluminum, steel. The 3/4. Here's the steel 3/4. Connectors with that, all the way. They have all your connectors, angle connectors. We talked, guys, about right angle connectors, straight connectors. That go with it directly with an angle connectors. Okay, go back again, Chad. So straight connectors, angle connectors, and so forth. Okay, and let me just see. Anybody has any question, guys, before I action? Let me move this one to the side so I can see. Any question? How about the next four? Make sure you guys are still with me. I didn't put you to sleep. Basically, let's just go maneuver one more time if you don't mind, and just go to Liquidtight. Okay, here. I'll go to, this is metallic. Here's Liquidtight, guys, and look at the material that they have for Liquidtight. The Liquidtight, conduit Liquidtight, size 1/2 inch, all the way conduit non-metallic. Let's say Liquidtight. Here's my Liquidtight metallic, and if you're familiar with that, this is Liquidtight conduit, size 1/2 inch, thread size 1/2 inch, length 50, flexible steel. So tight flexible steel conduit. Here's your connector that comes with it, special connectors. You guys are very familiar with the connector, special connector for Liquidtight, angle connector. So not install any of these. So it's a lot of right angle connectors, straight zero angle connectors, and all the stuff that comes 14. I think this is 45 degrees. There's 45 degree that we talked about, guys. I don't know if it doesn't look like 45, but it's a 45. It says 45 degree. So they have 45, 90, and zero angle connectors or straight connectors. So, all right, these are a couple of connectors that come handy with this type of looking at 73 for 50. Okay, so the Liquidtight is steel, all of it is steel. If you guys look at it, steel, most of it or all of it, Liquidtight, flexible, non-metallic. The ones that, if it's Liquidtight, it's steel because it's going to be a wet location. You don't want to put aluminum in wet location. So for the most part, it's steel. Here's the liquid non-metallic conduit, guys. That's the last one that we talked about. I'm sure you installed it. Here's this is liquid non-metallic conduit. Non-conduit, completely non-metallic. Thread size, it's 100 feet. It's a type B. Remember that we said type B gray, guys? That's what we were talking about, type B. That can be more than 6 feet. The connector that comes with it, special type of connectors. You install, some of you guys have installed a few of them all the time. Liquidtight, water is not going to be able to seep through. And look at the connector. It's almost $7 just the connector itself. It's 90-degree connector. I'm sure you can get a lot of other connectors too with it. There you go. So you're going to go all the way to straight connectors, 3/4 inch, and okay, straight connectors and so forth. So that's basically my Liquidtight. These are the types, and I'm sure you guys have installed a few of them. Go back all the way to conduit non-metallic, conduit Liquidtight non-metallic. I'm going to go all the way to tubing non-metallic. This is tubing non-metallic, not conduit. That's another wiring method, my friends. And flex conduit kit. Let's look at them here. That kit with the hole. It comes as flexible conduit, 1/2 inch, 6 feet, included 2 sleeves, connectors, all in one, so that you can connect just straight directly to the machine. It's a kit. So 2 connectors. I think 2 new connectors. So it comes with lock nuts and so forth. Okay, that's basically I wanted to kind of maneuver you guys through these babies here. Let's check on tubing. Tubing is different ways. This is your flexible metallic tubing. Flexible metallic tubing. This is flexible non-metallic tubing. It really looks like flexible non-metallic conduit. It has an article of its own. How many of you have used it, guys? But it's flexible. It looks like. So another way of method that you can use and so forth. So if you can see more, if you haven't, if you install it and get used to it, there's grainer, really nice pictures. That's what I like to use them all the time. Okay, with this, let me go back to you, my friends, and ask you any questions. Anybody have any questions, my friends? Any questions about what you said? I need to hear from all of you. With my friend, it's 7:07. Let's give you until what is it? I mean 8. Let's go 8. 3. Let's say 8:13. Just for let's take break guys until 8:13. And when we come back, we will go through the cabinet, cutout boxes, meters, sockets, and so forth. If we have enough time, I'm going to go to table chapter 9, table 8, and just do some examples there. Take your break for team. Okay, good. And go ahead and check him, please. Thank you, my friend. So we guys has basically not a whole lot to do with what we covered. It's cabinets, cutout boxes, and meter sockets. So about these, the cabinets are your panels, cutout boxes are your fuse disconnect switches, meter sockets, enclosure. We know what a meter socket enclosure is. To talk a few things, here's a good example of what they mean by this article. A few very important things to know. If it's cutout box enclosure, that's the fuse disconnect enclosure is used. Cabinets, we know what a cabinet is. It's a panel, an enclosure for a panel where you put your communication device. And if it's a meter, it's an enclosure where it houses your meter and associated equipment. Things about this article, guys, without getting into too much detail. Let's see into 312. So here we go, 316, 312. We're getting into a couple of things. The damp and wet location. If you are to install in this damp and wet location, surface type enclosure shall be equipped to prevent moisture or water from entering and accumulated within the cabinet of the box. So you need R in a wet location, so it's going to be in a design way where you don't have moisture dripping right into your equipment. So that this would be asked in the general exam, 1/4 inch space between the enclosure and the supporting surface. They want you to maintain. It will be mounted again in damp and wet location. They want you to mount it where it is for rust and so forth, to keep a space of 1.25 inches. Sometimes we put wood or something right behind it to maintain, guys, space. Enclosure shall be again weatherproof. Enclosure, if it's in a wet or damp location, it has to be weatherproof. So that's for all enclosure installed in large areas. Position in the wall, very interesting. So we know if it's outside, guys, how they have to be move them from. Again, I can't emphasize where we are. We're in a damp wet location. We're not in a dry location, so that's you're going to mean damp and wet location. Basement is a good example of damp location. A good example. Okay, if it's non-combustible walls, non-combustible concrete, the cabinet shall be installed so that the front edge of the cabinet is not sit back of the space more than a 1/4. So you want it to be sit back more than a 1/4 if it's non-combustible. If it's combustible like wood, combustible, it has to be flush with the surface. And has to do, guys, with the fire, spread of fire and so forth. In combustible, you don't want, if there's any arc spark right into the enclosure, you want it to be completely enclosed and it doesn't spread to the combustible material. If non-combustible like concrete, 1/4 inch, burn the concrete, there's nothing to burn. So very interesting. A 1/4 for concrete, non-combustible, and wood for combustible as flush. Anything else about that? Any questions about how we place these? Yes. Okay. That's for the 3 types of cabinets, guys. Also be closed, and I'm sure the inspector have called you a couple of times. If you have any openings which conductors shall not be adequately closed. So if through which conductors enter shall be adequately closed. So if you have an opening in the box and you do not use that particular opening in that particular box, you have to go ahead and enclose it. So there's an opening right here. I didn't use it. A conduit came from this side, no problem. Conduit came from this side, no problem. I have an opening here, so I have to close it. So into this one all the way, guys. So that's basically what I want you guys to share. So though I do have one more thing about this before I go to the gutter, which I know we covered some of the gutter, so I'm not too worried too much about it. I'm going to go to 2 very interesting tables. So I'm with this, guys, with I'm going to go up, share my tab with you, monitor 2. Monitor 2 is right in here in front of me. Let me drag my highlighter and drag you so I can see and put you right in front of me so I can see this. Okay, great. Grab my highlighter. Okay, very interesting table, guys. You're going to see this one all the time if you haven't used this type. This table, very important table right in here. This minimum, I want to read it to you. Minimum wire bending space at terminal and minimum width of the gutter. This has two very interesting things. One is the wire bending space, the space needs to wire bend, and the width of the gutter. So very interesting. Here's my cabinet. I'm right here, and here's my lugs. Look at my one table per lug. Let me go change it. So let's just get you this scenario, guys. I'm coming from underneath, right in here, 3-phase, and ignore the neutral right now. Let's put neutral. In neutral, each one of these conductors is as 500 kcm, 500 k and m. And directly the width of that gutter, where these conductors, you have to have a width where these conductors can carry. Here's my 500 kcm, right? 400 to 500. How many conductor per terminal? This is phase A, one terminal, phase B, phase C, and a neutral. So how many terminal? One wire per terminal. One wire is one wire per terminal. Can you guys see that? 2 wires per terminal, my friend Joe. This is your paralleling. If I want to parallel conductors, I put 2 wires per terminal. I'm paralleling. So the width that I need to pull the conductor in is at least 6 inches. The width I need is 6 inches. The 6-inch width I need to pull these conductors in. It's big for them to move in. So that's basically what, at least minimum. Again, this is just for the conductors. Doesn't include the material. So if conductors are coming in one area, you need at least 6-inch width. I know it'll be wider because of the overconduction device on the buses, guys. But that's the gutter. Again, the gutter, which is this case will be right. Usually, guys, right in here is where it is. This is the space right in here. If I'm bringing conductors, this is the gutter I'm trying to size right around the circuit breaker. This is circuit breaker. So it's basically 5. Anything else about this? How to use this one? 6 inches wide, 6 inches wide. Any questions? How about the next for Chad? Make sure they're with me. Fully full. Okay, great. I'll go erase this one and give you an example, guys. This is interesting because it's in your journeyman exam. No question asked. Same box here. Okay, and I got her right around it. This is my equipment, and this is my gutter. Conductors, let me go grab a different color so it makes it slightly different. And I am my conductors, and I enter this way. Is there any problem with that? I brought my conductors. I went that way. My 3 conductors. Okay. These conductors this time, I'm going to make each one of them is 4 aught. Each one of these conductors is 4 aught. Phase A, phase B, phase C. So you have phase A, phase B, phase C, and a neutral. Okay. Oops. Will somebody my stuff from me? Okay. Sorry that. So it came over here one more time. Here's my gutter. And I'm going to get from, look how I'm going in the direction. Okay. Look, I'm entering from wall. I'm not leaving from the same wall. Okay. This is where you can, this wiring bending. Then this was, these were 4 aught each. There's one terminal. Here's 4 aught, right? And I need 4 inch. So the bending space that you need, let me see, right from here, you use 4 inches for bending space. This table is when the conductor enter from the wall, as well as the gutter. So that this is also the width of the gutter. Can you guys see that? That gutter has to be 4 inch for conductors to move in. Any questions about this? Any questions about this? How about an expert Chad? You're with me? Okay, very important to know how to use this table. Very important to know how to use this table. Besides the pull boxes, guys, the pull boxes, they also refer you to a second table that we're going to be using. Any question about using this table? So I want to show you how to use another terminal. Let's assume, guys, the same scenario here that I did. Let's assume parallel more conductors. So I'm going to do just the same scenario, and I brought 2 conductors from every phase. So basically 2 sets conductors. Each one of them is 4 odd. Each one of them is 4 odd. So because of 2 sets, I'm paralleling. This is number 2, and because of that will be 6 inches. So my gutter now, that's supposed to be 4 inches. Now my gutter has to be 6 inches because paralleling. Is if you parallel 3 sets, 4 sets, 5 sets, all the way. And how to use this table? Very, very straightforward, no question. We're from the right. Let me tell you another table. I want you to watch how I entered from the right, guys. I came from the right here, from an angle. Let me just go to the second table. This is B. Now B is, a matter of fact, okay. Here's my table B. Here's my gutter, right, and I'm going to go enter my box. I'm going to go from the same. Here is phase A, phase B, phase B, phase C, phase C. I'm paralleling, and here's a neutral. Okay, so I have 2 sets. Let's and parallel 2 sets of 400. Either 4 conductors 400. I decided to pull full neutral. Okay, you guys look at, here's the 400. I'm running 2 sets, so I minimum width, bending space, and paralleling 200. If you go all the way under inches, because we're in America, and if you look all the way here, you need 13 inches. And then E, 13E, and E is 3 inches, and then for removable and lay-in wire terminals intended for only wire, bending space shall be permitted to be reduced by the following number of inches. So they allow you, that's only for this condition, guys, which does not might not apply to us. 13 inches. 13 for removable and lay-in wire terminals intended for only one wire, bending space shall be so. In this case, we have 2 lugs, and our space will be 13 inches. So you can tell big this has to be 13 inches, the gutter. Anybody has any question about how to use this one? That's basically how their bending space. They need this wire to be able to bend your conductors. You bend them since they are not going an angle. You're going to be bending them to tie them to the circuit breaker. I want to bring to your attention, my friend, that right in here there will be circuit breakers or lugs. These will be tied to, each one will be tied, and there will be the neutral here to these to the neutral, right? And we terminate these very important tables, and don't forget to use them. So then, and if we all other conductors here are aluminum. Here is aluminum, guys. They're using compact stranded. This only compact stranded aluminum. This one. So with this, I'm going to go back to my presentation and ask you one more time if anybody has any question. Any question, my friends? before we move into the auxiliary gutters. So these two tables are very interesting, guys, in terms of bending radius. And table B, 312.6a, as a matter of fact, will be also used for pull boxes. When we find pull boxes, which is going to be next week, as a matter of fact, we're going to be returning back to 312.6a. Okay, so now I walk you guys through the gutter, and gutter is an extension. So this article covers the installation, construction of metallic auxiliary gutters, or remember the word non-metallic, again, their associated fittings. Do we find a gutter? I told you guys last time when I think I walked you a quick split. So we said it's a metallic one. Obviously, it's a sheet metallic enclosure. It's not a conduit. It's an enclosure used to supplement wiring space look at where? At meter center, cabinets or distribution centers, switchboards, or similar points of systems. Wiring system. The enclosure has a hinge or removable covers like a panel for housing and protecting electrical wires and cables and bus bars. Bus it together. The enclosure is designed for conductors to laid in place after enclosure has been installed in a complete system. Very interesting. Metallic, the same thing, guys, except it's a non-metallic. The same mission. Again, it's feature centers, non-metallic, distribution, switch gears, similar equipment, and it has an overcome protection device in it, guys. Housing, protect bus. Can't define that you can put bus bars in it. You can't put circuit breakers in it, but you can put bus bars, cables, or wires. Cables or wires. Bus bars, cables, or wires. Cable could be a multi-wire cable, or wire could be just a single conductor or a little wire. Okay, basically the two different gutters. Sheet metal gutters, can I use it indoor? Bring it on. Outdoor, no problem if it's rated for other use. In location, no problem. You can use it if it's in a wet location as long as it's rated for wet location. Not like I can use also indoor, and I can use also outdoor. Not look at the word not permitted. They don't want you to put switches or overprotection devices in them, applies or similar. This is not meant to be a panel. It's not meant to be a machine. Very interesting. And if I don't know if you guys remember when I talked about it, I said there's a limitation for 30 feet you can go. You cannot extend the gutter all the way more than 30 feet. 30 feet is an eternity. It takes a lot of wires. So 30, you can't an overcome protection device in it, or disconnect or similar equipment. Disconnect, overcome protection device, similar equipment. It's meant to be a panel, basically. It's not meant to be a panel. Anything else about this? And you said the difference between the gutter and the wire wave? Anything about this? So, good application, guys. We've used them all the time. You have this is equipment. You add an existing. This is a 2,000 amp switch gear. You an existing piece of equipment, and you put a gutter right in between here, and you a feeder from this one. See, I want 800 amp feeder and 100 amp panel here. Like that. And you can pull your conductors, extend it. You can bus them. This could be here buses, guys. This is covered. This could all the area here. You can bus these two systems. We were in projects where we actually bus them together, not cable them, bus them. So that's the occasion for it. There's where you can come from the bottom here and extend it through there and take your conduits from the bottom. We've done a few of these. And you can use a wire wave for this, as a matter of fact. Another gutter, you extend it and you collect your conductors and they go through. So, how many use gutters? You guys have used gutters? Few Okay, it's handy, especially on major equipment like 4,000 amp switchgear, guys, pulling a feeder, 1,000 feeder cover, and buying another piece of equipment to extend the switchgear is a you know, it takes a few modifications, but it's slick. That's one end. The other end is you pull your circuits into and just pull branch circuits and feeders and so forth. Number of conductors, sheet metal gutters and non-metallic. The sum of the cross-sectional area containing all the conductors shall not exceed more than 20% of the conductor fill. So they want you guys to fill more than 20% for this baby. That percent comes with a that fill of 20% for the gutters. They don't want you, you're not permitted to fill more than 20% of it. So the sum cross-section area shall not exceed 20%. The weight factor shall lie only where the number of conductors, neutral, and fluid are exceeding. So that's basically that 20% fill. No more than fill than 20%. How to apply this one, my friend? So if you have say 6 by 4 inches, 6 by 4 inches, that gets you 24 inches squared or squared inches, and then you take 25% of this, 0.2, which is 20% times 84. You can only fill 4.8 square inch. What that means? What means is I can go and find the cross-section area of all these conductors, you add them up, and shall not exceed 4.8 for this gutter, auxiliary gutter. Okay, so basically, I don't know if we have it in here. So that's basically the fill for them. Very thing, guys, for sheet metal gutters, 30%. You guys read that 30% high conductor, carrying conductor, no weighting, up 30%. So they allow you to put 30 high. Like wireways. Wireways are the same. The rating, if it's metallic, if it's non-metallic, you're on bond. So you have to durate immediately. If you're non-metallic, you have to durate immediately. Every more than 3 carrying conductors in non-metallic, durate. Eric, my friend, that kind of lets you of non-metallic wireways. Non-metallic wireways. Let me ask, how many of you guys have used non-metallic wireways? How many of you guys have used non-metallic wireways? Anybody have used non-metallic wireways? Not the metallic one, non-metallic wireways. So probably that's the disadvantage of using it, because if you want to pull like 20 conductors, now cutting your ambiguity by what, by 70 or so. If you go to the table, what is it? Table 315.b. You go to 315.b, and you lost a lot of amps if you put 20 of them, 50%. So if you 20 conductors, or just let's stay with the 30. Say if I decided to put 30 hot, including neutral for harmonics. If I put 30, I'm cutting my amps for 45 amps. What does that mean, Chad? If I have a 10 amp coming out of a conductor, just for the heck of it, I have only 4.5 amps I can use. So a conductor that's rated for 10 amps, I'm just throwing this, I can use 4.5 amps of it, less than a amp. Well, you just thrown a lot of cover in the ground. You can't use it. It's not coming, and you haven't used it that much. So if it's metallic, no problem, 30, and you still kick it. So that's basically it in terms of the way. Sheet metal raceways, guys, support shall be supported at intervals not exceeding 5 feet, non-metallic 3 feet, no problem, and at both each end. So at each end and every 3 feet. So here's my box. each end, 3 feet, no support needed, 3 feet here, support at ends. If I have a box over here, 3 feet support, and after that, 3 feet support. Here's my 3 feet, here's my 3 feet. In no distance between the support be more than 10 feet. In no case shall the distance unless listed. And here, this is where it confuses you guys on the quiz. It's feet, but they have this tiny little. It's listed for other servos. So if the equipment is listed, if the wire, the meat, the non-metallic, the non-metallic is listed, guys, for use. The non-metallic is listed for use more than. So you're going to support it every 3 feet from equipment. I'm going to go all the way up to 10 feet. Only if it's listed, no more than 10 feet. Only if it's listed. I can emphasize the word only if it's listed. Only if it's. Any question, guys? Anybody has any questions? Any question about supporting that baby? Any questions? Security. So that's a few things about the gutters, guys. Expansion fittings, you have to provide an expansion fittings, guys, based on for the non-metallic. It's a change or expansion or contraction because of temperature more than a quarter, So it will shrink or expand more than a quarter. Then you have to provide an expansion fitting. And expansion fittings, my friends, expansion shall be installed where extension expected length is going to change quarter. So you have to provide an expansion fittings for it, like any other conduit. In the gutters, I can't fill, if I'm doing splice and taps, I can't fill more than 75%. If I have bare conductor, taps shall leave the gutter opposite their terminal connection, and the conductor shall not be brought in contact with uninsulated carrying parts of the different of a different potential. Uninsulated carrying parts of a different potential. So that you have separation. If you have different voltages, especially on all the conductors are rated for 600 volts, but if you have 600 volts, 480, 277, 208, 120, make sure you're not going to be touching each other. They can touch, they're insulated, but if they're bare conductors or bare bars, you're going to short them. Any questions about that? Any questions about that? Suitably identified tabs shall be suitably identified at the gutter as to the circuit of the equipment that they supply. If you have tabs, overcome device, tab conductors from conductors in the gutter shall be provided with an overcome protection device. And tab your conductors from the gutter, you have to protect them with an overcome protection device. So I can tap from gutter. Special taps shall be permitted within gutters where they are accessible. So and here's my gutter over here. That's why we use the gutter. I'm going to pull my conduits over here, and here's my disconnect fuse over here, and here's another conduit, my friends, and here's my disconnect fuse here. And again, and if my conductors are coming here, and conductor coming here, and here's my feeder, and here's where I'm doing my taps, and this is where it goes all the way through. And you have an overcome protection device, a fuse or a circuit breaker right in here. Okay, basically taps them, identify them. Gutter grounded. If you have metallic, shall be grounded. You have together the metallic gutter, guys, connected to the equipment conductor. The metallic auxiliary gutter shall be connected to an equipment grounded conductor, to an equipment bonding jumper, or to grounded conductor. So if you have a gutter, the gutter itself, you have to tie it to an equipment grounding conductor. An equipment grounding conductor. Bonding jumper if it's not. So it has to be tied Again, if it's between two different, it acts itself as a grounding system, guys, like any panel. So you have to add a third one. So if you're tying it between two panels, it's metallic, you have to act as an equivalent ground conductor. If it's non-metallic, then you have to bond two equipments with an equivalent, a grounding conductor, or a bonding jumper. Bonding jumper, equivalent bonding jumper between the two elements. If it's non-metallic, if it's metallic, to be securely fastened in both sides, to be metallic, electrically and mechanically connected, so to provide a conductor, the grounding conductor. The grounding conductor. Construction, again, electrical and mechanical continuity. It has to be substantial construction. The material that's made out of smooth, rough edges. We don't want to damage the conductor. Covers, have a cover and clearance of light parts. If inside your panel, remember we have bars. Here's phase A, phase B, phase C, and then neutral. You have to maintain the clearance between these uninsulated bare live parts. Uninsulated bare live parts that we do. I'm going to leave that one. I'm going to bring to your attention, guys, that cover. Remember, CU cover. This article can carry 1,000 amps. Each 1 square inch of cover. If it's 1 square inch of AL aluminum, okay, 70% of it, which is 700. And I give you, I know I talked about it last time. That was on my master exam when I took my master exam. So if you guys a cover bar, if they have a cover bar 4 inch by half, just let's say how much current it then carry. So that 4 by half, that give you 2 inches square. Take the 2 and you multiply that 2 by 1,000, and then this cover bar can carry 2,000 amps. 2,000 amps. Any guys about this? Any question for Chad? Any my friend? Basically, let me see. Okay, that's okay. Basically, my friends, as what we have about the bus, the gutters, and the bus width. I know we talked about it last time too. Any questions, guys? No questions. I know I have a poll to give you, but I just want to quick, guys, very quick, go to chapter 9 and through the sizing the conductors. So I'm going to go quick and get you this stuff, and then I will get you to how conductors that we were just talking about, sizing conductors, and make sure that we do size conductors. Okay, so for sizing conductors, the table that we were looking at, here's what that table keeps saying. Go to table, where am I here? Go to table 1. It will tell you if you have more than 2 conductors, you can't fill more than 40%. Remember one? If you have 2 conductors, 31. If you have 1 conductor or cable, 55. So that's a very interesting one here. Remember, guys, we kept talking about bending radius, and we said if you have a flexible metallic conduit, for flexible metallic conduit, the radius, minimum radius is other bends, and that will get me for 24 inches. For the bending radius, here's all the conduits, guys, to do your calculation, how many conductors can fit in a conduit. I'm going to go to ENT, flexible metallic conduit. Here's flexible metallic conduit. And a few things. Here's my flexible metallic conduit. I will bring to your attention, guys, it starts only with, it starts with 3/8 here. The 3/8, for the 3/8, we go to a different location. So say if we have a 2 inch, And let's say that I'm filling 40%, which is more than 2 conductors, and then the amount of correction area in that I can fill is only 1.307. It was a nibble, which is 24 inches. I can fill up to 60%, and that pumped me up all the way to 1.961. Only if it's 24 inches here, 24 inches conduit or less, just a little nibble for or less. Guys, let me see if anybody has any questions. Any questions over the next for Chad? Make sure I did not put you to sleep. Basically, what a cross-sectional area is. Now, yesterday talking, guys, if I will find how many conductors I can fit, multiply the number of conductors cross-section area by how many conductors I have based on the type, and then I come over here and I find my conduits that need to fit this conductors. Table number 1, the other table, and you can see, guys, here's intermediate. This is the LFMB. Remember, guys, liquid flexible nonmetallic conduit B, and here's A2 is here. Liquid flexible metallic conduit by itself, not the B or the L. So move all the way rigid and PVC, HDE, and bunch of other conduits, guys, as you can see. The last thing I want to show you is table 9. Table 9, guys, if I have the cross-sectional area of a conductor, very interesting, of my conductor, and I'm going to just highlight, I like THHN, and conductor is 500 kcm by THHN, 500 kcm, okay, and cross-section area of this conductor, 500 kcm, is 0.703. So I have 4 of them. You move this one by 0.7073. That's easy to do, right? Your calculator handy. So 0.7073 times 4 equal. That gives me 2.8. 292. Okay, so that's basically how much I get. 2.82. Now, if I want to go find, very important, remember this number, guys. I'll go find myself a conduit, flexible metallic conduit that can fit them, if any, flex. So I have the 2.829 by multiplying M4 of them, THHN. So I'm going to go directly back and all the way to, I'm going to go away, my friends, all the way to the flex. Okay. Flexible liquid. Let's do Liquidtight flexible metallic conduit. Let's Liquidtight flexible metallic conduit. I need 2.8. If you guys remember the number, say I want to use a Liquidtight flexible metallic conduit right in here. Liquidtight flexible metallic conduit. I need 2.89, 2.89, 2. That's it. See here. So 2.8. Actually, I can go that, so I'm going to go erase that one. I'm going to go to 2.82. Here's 2.9. That's it. That's one. Sorry. I'm going to go Chad. I think Chad is getting okay. Let's go get 2 is my 2.9. That's it. So 2.8. That will be covering it. And this is the inches. I have more than 2 conductors. Perfect. And cross-reference this. If you keep going all the way, you're going to find yourself a number 3 conductor. To fit these 4 conductors, guys, number 500 kcm, we took the example, THHN, using flexible, Liquidtight flexible conduit, I need size 3. So that's basically it in terms of sizing. And I know I'm almost running out of time, so I might not be able to give you the poll, guys. But any questions, I will make sure that you know how to do that. Any questions? Questions how to use it? Section area, the blind environment conductors you have, and then you go to the table for that particular conduit that you want to fill, and yourself a conduit with that particular size. Okay, guys, I'm going to see if all your conductors are the same size. If all yours are the same size, you don't need to do. You go directly into NXT, and for XT, guys, I want to make sure. If you look at when this is EMT, then we have the asterisk here, or the little star. This is for compact conductors. These special type of conductors, compact. So, and you can see all the conduits that God created are listed in here. That's where you start point. Every conduit has two tables, one for compact conductors and one for non-compact conductors. All right, so if you guys, let's just take an example here. Since we were using flexible metallic, let's go all the way to flex and see what we can do for flex. Keep going all the way. Okay, what is this? This is EMT. EMT still in the EMT business. ENT, we don't want ENT. So here to find, trying to see, okay, ENT again, the compact. There's a few of them, guys. You can see the flexible metallic conduit. There you go. The flexible metallic conduit, guys. Let's say here's my flexible metallic conduit. Flexible metallic conduit. Let's see how many conductors, 500 kcm. Insulation this time I will decide to use RHH. Okay, and conductors I have 4 conductors that I want to install, and if you're referencing it, you need 3.5. You need 3.5. 3.5. So I don't know if we go to the Liquidtight, the one that I use, if we can find it and see with 3. And I'll be interesting to see if we can over the same number. A flexible conduit for compact. Is it compact? I hope it is maximum number of conductors, rigid, and so forth. So this is really interesting. You can find all the. Okay, there you go. All right. Liquidtight. Here you go. Liquidtight flexible This is the non-metallic. Liquidtight non-metallic conduit. All right. Non-metallic conduit. Here's my non-metallic conduit, guys. B. Here's my non-metallic, that B, the common one. Fixture wire, number of conductors. So we have my 500 kcm, and it doesn't even give you there. Does give you 4 conductors. It limits you for this one. It limits me to number 4, number 2. That we cannot go for more than number 2. Conduit, which is B, cannot go for number 2. So you guys, here's the P and number. Okay, the same thing. This is the compact conductor, the same conduit. We go all the way to 2, so it seems you're limiting us to 2 here. Anyway, you get the point, guys. I don't want to have time here. Okay, so basically. No, I didn't give you the last poll, but you guys can. I trust you that you're going to be able to do them. Anything guys about how to find how many conductors fit in a flex? Questions? I can't find that one. To find conductors fit in a flex, you're going to go to NXT if all of them are the same. If different, then you have to calculate them. Find the cross-sectional area from table 5, multiplied by how many of this conductor you have, then add them all up, because if you have 2, 3 different type of conductors, like number 4 and number 8 and number 500 and so forth, and then go to table 4, after the 40% fell, make sure you find you have a conduit that does not has enough room in it, meaning the cross-section area of the conduit that you choose must be more or equal to the calculation that you did, to the calculation that you did for the conductors. Anything else? I know the poll because I really wanted to go to chapter 9. We kept talking about chapter 9. Okay, with this, friends, you meet with Mr. Curry has come to an end. I encourage you to look at the exercise in page 312. Read review of what we have just did, guys. That's on all this good stuff and what the largest length of half-an-inch liquid specimen allowed in 20 amps and for ground conductor. So there's really nice review. So please you touch on that one. And number 12. And okay, and that's basically all we have. Next week, my friends, we're going to continue talking about pull boxes. So when you learn, well, we will go over how to size a pull box. If size the equipment grounding conductor, yes, you can go to table 250 122. Okay, so this is how you size the equipment grounding conductor based on the overcome protection device. So you need to know the overcome protection device. That was the question. Okay, so next week, guys, we're going to talk about pull boxes and J boxes. I'm sure some of you, if you went to technical college, you are sick of sizing J boxes and pull boxes. But I assume you guys don't know it, so I'm going to go over it one more time. And that's not enough. No problem, J. Okay. All right, that's basically all I have for you tonight. You guys can hang around if anybody has any questions. Next week is going to be pull box and J boxes. Get ready. Your quizzes are doing good, so keep doing the quizzes. I just remind you guys with the homework, so please, if you have not, I told you the homework is going to be until the end, and you're getting the homework. So when you're done, just shoot it my way via email. I collect them, and so I just collect them basically. So send them to the channel. That's all, my friends. Thank you for listening to Chad, and you can hang around and chat with me. Otherwise, good night, and see you next week. Eric, mind you can download the homework. Eric is asking about the homework. The homework from MEA website I have for you guys. Anybody does not know where to get the homework that the MEA is mounting for you guys their site. My homework is that we created it this year. So at the end, guys, no rush on it. So I'll receive it by the end of the school year. That will be great. Okay. Okay. Just email Amy and she'll walk you through how to find it on the network. I don't know how you guys see it. Amy is in charge of this. So thank you.